Hey everybody, this is Larry. This is day 23 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. It looks like it's gonna be oh, let's see. Well, 36 valid Sudoku is the problem for today. Let's see kind of what it is. Do we just have to validate, or is it Oh, so true false meaning that is right. Okay, so I mean I think this is not that bad actually. The other one with dancing links, and well, you don't have to go dancing links, but dancing links being one of the Knuth's algorithms for, and Sudoku is one of those examples they put. But I'm not gonna get into that today. I hope everyone's doing all right. Yeah, I don't really have much to say other than let me know in the comments if you've been watching the World Cup. It's been a couple of upsets so far. The big one being Argentina. So I don't know. I'm a big Messi fan. In case people are curious, I'm rooting for Argentina as well as USA, and yeah. Let me know in the comments what team you're rooting for this year, this World Cup. Anyway, okay. I mean, this is pretty okay. So we just have to check. We have to just yeah, we just have to figure out, right? So basically, so it's always gonna be 9, right? Yeah, like it isn't some crazy ones. Okay, so basically basically you have to map in 3 different ways whether they're uniqueness, right? So for example, we have rows. How do we want to do it? Maybe I'll just do something like of a set or something like this. And of course, row sub x is, or row sub x is going to be the rows, and then one for columns. I think this is pretty, not surprised if you have seen something similar before. And then the other one that I want to do is, I was going to say diagonal by accident, but I mean boxes, right? So, what do they call those? You just call like box? Maybe I'll just go do it this way, right? And basically the easy way for me to think about, and for rows, right, board of xy, right, or maybe even just like y years, you could put xy, and then if we in rows of x, then we return false, right? If we in columns of y, then we return false as well. And then the other one is the boxes, right? How do we map them? Well, let's see. So, so it's just divided by 3, right? On the x and the y, because now you're basically mapping a 9 by 9 thing to a 3 by 3 thing, and then every 3. Yeah, I think that's right. Let me know if that's wrong. And then you can, I mean, and now you have a, let's just say, I mean, I'm gonna write it out just because it's easier to remember for the viewers at home, and also the coder here because but yeah, but then, and then here, if and then maybe something like n cell, which is the cell, which is nx times 3 plus ny or something like that. I mean, as long as you're consistent, it doesn't really matter. If we in boxes of nc, return false. Otherwise, yeah, boxes of nc dot add v, and then return true. I think this is roughly right. Maybe I made some mistakes, but I think that's roughly right. Okay, well, that didn't go well. So this should validate. What am I returning false on? Is it this one? This one is the most sus one, but let's kind of see. No, it didn't print there. So where did I return false? Did I have a typo? Okay, that looks okay. Huh? So that isn't. All right. Well, I guess today we'll see. Do I have a typo? So row 0. Oh, I am being dumb. I don't. Okay. I mean, that's fine. I for some reason I didn't really look at the inputs, and there are these dots. So yeah, okay. If we as you go to then we just continue, right? Obviously, I'm just making silly mistakes today. Okay, so that looks good. Let's give it a submit. Not because I'm probably like about 80% confident, maybe 90. But what I meant there is that like I'm just a little bit lazy on the 10%. Otherwise, we probably could test some edge cases. But looks okay clearly. So 967. Let's go with the complexity really quick. I mean, let's see, right? This is going to be O of 1. This is only assuming that default dict, which is a dictionary and a set, both are O of 1 operations. You could kind of see what the actual implementation is, but assuming that then this is going to be O of 1. And if this is not O of 1, you can just in the interest of argument, you can just say that I would implement it in O of 1 kind of way. I know that there's a lot of caveats there, but my point is just assuming this is O of 1, then this is going to be O of 1, this is O of 1, and this is all these are O of 1. And actually, yeah, I mean, I kind of use set and default dict here, but to be honest, you could just use a matrix of 10 elements, right? Like 10 by 10 or something like this, right? Or 9 by 9 even, right? So yeah, and then 9 by 9 here, 9 by 9 here, 9 by 9 here, and that's all you need really. And then clearly everything is O of 1, and clearly we have linear time and linear space, right? And when I say linear time, linear space, I mean that the size of the it is linear in the size of the input, r times c. I know that this is 9 square, and sometimes people see the square and they say it's quadratic, but it is linear in the size of the input. And in terms of space as well, because we have these things, and they only are bound by 9 square, even though the implementation is a little bit, looking like this. Cool. That's pretty much all I have for this one. Not going to do an extra problem today because I've been a little bit lazy today on the gym. I mean, I'm still going to go, but a little bit later just because tired. One of those tiring days where just trying to muster enough energy to go to the gym kind of day. Hope that that's probably very relatable, but if that's relatable, let me know. But yeah, anyway, we'll see you tomorrow. Stay good, stay healthy, to good mental health. Goodbye and take care. Boop.